Using the multimeter in no power supplies, you must be know there is no power supply. It's safety. All the difference for you, all damage. Okay? You can test the resistance of CE between the AC and the DC, AC and DC. You can test the capacitor of this link. You can test the resistance between the power terminal to the ground. Test control power supplies 24. You can test the resistance of the CT. Okay, very useful, but it's not effective completely. Okay, just the additional tools to assist you identify what fault happened. Simulation mode of the dynamics converter provided for the test. Yes, you must disconnect it from power supply, from the power grid. And you must power on the control power 24 to the DC link. Operation mode VF. So in the simulation mode, you can enable pulse to make IGBT run. You can using the oscilloscope to test IGBT, to test the IGBT output. Okay? Yes? This picture we also talk about. You can using the starter to choose the CT feedback, actual current, to check maybe the IGBT or CT fault. This picture we just have we just discussed. This picture, you can see, we can trace the pulse levels of the motor module to trace the 3 actual current, and also we can, with the pulse disabled, to trace it. You can see the parameter, the offside. Yeah, this is the fault. The one CT is offside fault is very, very high. Okay? Case 6. Yes, an abnormal load on the motor module caused to be burned after running a period of time. By this using the DCMA to monitoring the different motor module. You can see the number 409, 410, and the different production. You can see the key indicators of operation in the system: load rate, temperature of IGBT, VDC voltage. Yes, you can using these 3 trends, long-term monitoring the trends. We can see what happens. We can see some devices in serious overload. This one serious overload, and at BT, the temperature is a little higher than normal. This is overload almost two times, and the alarm temperature alarm threshold reached. So this temperature may be in operation times, everything is okay, no fault happens, everything is no stop, but for periods of time, running period of time, this model will be broken. Actually, in the field, this model fault. Case 7. Pollution causes burning after running for a period of time. Okay, you can see this case involves environmental pollution caused by operation of equipment. You can see this part accumulates and leads to problems. Accumulate lots of dust. Leads to problems after a certain period of operation. And there are some conductive dust. And also have some environmental humidity. Okay? So the degrading of the hardware of the power unit. At last, running for a period, he had done and broken. The fourth step, service and optimization. Okay? This is ALM. Reports overvoltage during the motor operating. Let's review the working mode of the ALM. There is two working modes, motoring and generating mode. Normally, during the monitoring mode, the dislink voltage will be decreased. But in this field, overvoltage happens. You can see the ALM enable running load. Motor mode, there is active power 8 more than 0 motor mode. Okay, but overvoltage happens. This is a lifting application. Hoisting application. Okay. Let's make a detail analyzing producer of the fault trigger. There are the 4 producer. As one, you can see where the lifting as motor mode, the VDC voltage will be decreased. Yes, you can see actual decrease. Phase 2, with the VDC controller, active power of this link will be compensated. You can see this is a compensated control. At the same time, active current will be increased with modulation. Modulation factors increase. Okay, you can increase, decrease, increase, compensate for the decreasing of the VDC voltage. Page 3. To ensure the modulation margin, additional VDC sub point will be increased. This one. You can see this increased additional sub point will increase the sub point of VDC voltage. Page 4. When the actual current catch the sub point, the modulation you can see. When they catch sub point, the modulation will be increased with the steady VDC voltage. But you can see there is a very high fluctuation directly in the overvoltage current. Through analyzing the fault producer, we can make a conclusion there is no hardware fault. But the performance of VDC controller not so good to match the load requirement of this link. So just to give the instruction for the customer. One, you can using the load pre-control in the area. Two, optimizing this controller, PI controller. Three, optimizing the modulation, the current controller. Optimization, modulation depth resolve controller, this one. There is a integrator controller, or some filters, or some additional computing controller, control output. The fourth maybe the configuration of the area, the capacity not enough. Re-selection, large one. 5. Optimizing the multimodal of the disk. So we just doing the optimization with this controller. Everything is okay. Case 9. Yeah, there is a serious mismatch between the speed controller and the load characteristic. This application is the large moment of inertia. You can see unstable, critical stability. Perfect. We just optimizing the PI controller of the speed manual. Everything is okay. Not hardware fault. Case 10. Impact of PWI on the insulation of multi-windings. You can see in this field the terminal voltage of motor checked with the oscilloscope. You can see that this link voltage during braking is higher than normal. And this link voltage transfer to the motor terminals with reflection because of the different resistors between the cables and the motor windings, which will result over voltage, not will exceeding the limits of the design motor. Okay, the permissible peak voltage and motor model, this one exceeding the limit. So the winding broken. Further, heating the whole motor. Of course, there is other reasons also. Yeah, there is some overload happened, combined with the motor winding broken and overheat of the winding. show the status of the motor, just like this. Completely burned. Case 11. Impact of PWM on burning out motor. Bearing. Okay, you can see. This is the bearing current. Bearing current. There are 3 types bearing current. Normally caused by common voltage of PWM. This will damage the bearing. You can see 3 types. The first, EDM. EDM means each edge of the 3-phase ground voltage and winding charge or discharge the capacitor. This is the model of the bearing model. Okay. Discharge the capacitor, the CB, of the bearing, where the capacitor, the CWR, discharging and charging between the winding and the rotor, okay? In the worst case scenario, the bearing voltage can reach such high values that lubricating films on the bearing breaks down and the capacitor, CB, and the CRH are discharged by false high current pulse. This is the EDM. Normally EDM just for small freeside motor. The second type is the circuiting. In the same way, the motor cable capacitance change their polarity with the average reaching edge at the inverter output. The polarity of the capacitance CWH, this one, between the winding and housing, is also reversed with very switching edge. This creates kind of high frequency capacitive leakage current between the winding and housing, and thus to the ground. This leakage current leads to the magnetic imbalance in the motor, which induces the high frequency shunt voltage, V shunt. If the insulation capacity of the lubricating films on the motor bearing cannot withstand this shunt voltage, the capacity will circular current flows through the circuit, shaft, bearing, motor, housing, bearing at the end, and drive end, and shaft. This is for the larger free size motor. And the third type of the bearing current is the rotor shaft current, the yellow one. You can see the high frequency, the capacitor leaking current flows through the capacitor CWH between the winding and the hose, cause the circular current must flow from the motor housing back to the inverter. So there is a very, very small resistance for the high frequency current using the coupling, using the gearbox, using the machine to back converter on the rotor shaft current. You can see this is what fault the bearing damage. how to resolve it. Yes, the first equipotential bonding will be strongly recommended to solve the problem. Siemens recommended. Of course, there is some other merits. Okay, this is equipment bonding. You can see this is the 0. The black type is just protect Earth. The other colors is just equipotential bonding. You can see, okay, there are some requirement for your reference. Okay, I can see there are some other merits. For example, you can configure the insulation variant for the motor, and maybe we can configure the output, the filter of the motor output to decrease the stress on the motor winding and motor bearing. And we can using the grass. Yes, we can using the ground brush to circuit the bearing current to resolve it, to protect the bearing. Okay. So. Yes, this is summary, just the same, the first part. Yeah. This part will, okay, I'm finished. Alison, any question?
刘工
OK， 你说。
现在1个半小时了，要不休息了15分钟？还是？
行。
休息了15分钟，咱们再继续吧，是吧？
我这边分享的东西就完事了吧？咱们所有的课程都完事了吧？training。
之前我看那个课件说是还有个原理图，是
原理图就是在咱们讲第一部分的时候，我已经说了一部分。
哦，对，那就是咱们休息了15分钟以后，还是让他们有什么问题问不是？
可以啊，可以啊，行，就最后讨论呗。好的，
好嘞，我们得先休息吧啊，哎。
那让他们集中一下问题，写成这个集中一起。
都有。其实刚才我听过那个办法挺好，就是可以利用15分钟的时间，把那些问题也可以先汇总一下。这样的话呢，您给那个。
Any question you can write down, and after 15 minutes, we will reply one by one.